to figure out how to reduce costs dramatically across the business. I had 30 days to come up with a plan to reduce my development costs from $100 million a year to 50 to 60. At the same time, we were doing a complete re-architecture of the system and throwing away the old code base and trying to figure out how to bring it up. I'd watched this business from the outside for a couple of decades and realized it was a constraint to the business. We couldn't move forward, we couldn't move faster. We needed to do something fundamentally different. Up until this time, HP had been trying to spin their way out of the problem with no success. We needed to engineer a solution. We needed to take a completely different approach. And we started applying what I would call agile and DevOps principles at scale. We didn't necessarily spend a lot of time on it at the team level, but we got my staff, over 800 people, thinking through how do we constantly figure out how to improve, because there was a $2 billion business standing behind me. We'd thrown out the old architecture. We needed to get the new architecture out. And I was looking for anything I could possibly do to improve the effectiveness and productivity of the organization. And we went on a journey of continually trying to improve that. And after about 3 years, we looked back and we fundamentally changed the entire productivity of the organization. We'd reduced the cost from $100 million a year to $55 million a year. Firmware was no longer the bottleneck. When we wanted to add a new product to our plans and to our future roadmaps, it was easy for us to look at it and say it does not take a lot of resources, so we can add them. We were starting to release 140% more products than we were previously supporting at about half the cost. And the number and the capacity that we had for new features and new capabilities had gone from about 5% of everything we were doing to about 40% of everything we were doing. So we started saying yes to the business in a lot of fundamental ways. And as I checked with my co-author a couple of months ago when I was back there talking about how things were going, they'd actually drained the swamp of marketing requests, and they were actually working with the engineers to think up new ideas that they could add while they continued to reduce costs over time. Pretty dramatic improvements in the productivity of everything we were doing. Now, the interesting thing is, as we look back at it, we had a lot of teams that were implementing agile principles at the team level. They were doing burn down charts, they were doing stand-ups, they were doing scrums, they were doing all those things. We had some other teams that really weren't implementing or practicing those team level rituals. And what we realized was there was not a dramatic change in productivity between the teams that were doing all the agile things and the teams that weren't doing all the agile things, but 2 to 3x improvement in productivity at the overall organization, which led to our conclusion that in a large enterprise, how the teams come together to deliver value is a first order effect. How the individual teams work by themselves is a second order effect. Now, this is a case when you have more tightly coupled architecture that requires large parts of the organization to develop, qualify, and release code as a unit. It doesn't necessarily happen when you have organizations that have microservices architectures that you can have small independent teams develop, qualify, and release code independently. So if you're thinking of a large organization that's tightly coupled, you need to think about applying these principles. If you're more in a situation where you've got a very clean architecture that's very loosely coupled, you can think about more how do you empower the team and get people supported and make those types of things going. So when I talk about the agile principles, I think it's pretty straightforward, and Dave can catch me if I get this wrong because he was there from the very beginning. Everybody understands the basic waterfall methodology and the realities of waterfall, that when you try to lock in all 3 of those triangles and there's uncertainty and discovery in the process, you either work the teams to death or you slip the schedule, or some combination of both. And the basic principle of agile is to break that up into smaller iterations where you're releasing on a more frequent, ongoing basis. Well, if you have a large, tightly coupled system that includes hundreds to thousands of engineers, the small agile teams aren't necessarily going to think about how they coordinate and integrate and release their code on an ongoing basis. If you walk away from anything with this one talk, walk away with this, that in a large, complex organization, Scrum does not equal agile. And if you're not really careful about how you do it, you're going to end up with the classic mistake that's made in most enterprises of creating a water scrum call process. In this process, you have the team stand up, doing really good iterations, but they're still committing to plans that are 12, 14, 18 months into the future, and they're still having a hard time integrating and releasing their code on a more frequent basis. A different approach, and the approach that I'm presenting in my second book that's coming out, Leading the Transformation, is you really shouldn't do Agile. You shouldn't do DevOps. You shouldn't do Lean. You shouldn't do any of those things. We're managing a business. We're part of a business. You should understand what you're trying to achieve for your business. And if you can't think about why your current development processes aren't meeting the needs of the business and clearly identify that, you shouldn't go off on a journey just to adopt the latest ideas or approaches. You should really start with why your current development process is failing to support the business needs that you have. And get that very clear, because a transformation like this is going to take a while, and you always need to look at what's the long-term vision, what's the long-term direction, what are the things that are in the way of getting this done, and what are we trying to achieve. And then once you have the business objectives, you can start to look at your toolbox. And your toolbox has Kanban ideas, Lean ideas, Agile ideas, DevOps ideas, and you should take the tool out of the toolbox that's going to fix the problem that's your biggest barrier to making your business improve. The next thing I would say is you need an enterprise-level continuous improvement process. It's not enough for each of your individual teams to be doing retrospective and doing reviews and trying to improve. Because if you're going to make these changes in large organizations, it's got to work across the organization, and you need your executives engaged in part of the process of setting the objectives and working with the organization to figure out what's getting in the way of getting things done and what's not. And then if you have a good process for changing your planning process where it's responsive and reactive to what's going on and prioritize backlogs, and then you have a good process for releasing code on an ongoing basis. In the enterprise, it does not need to be any more complex or difficult than that. But you need to continually learn and adjust. You need to start where you're going to have the biggest business impact, and you need to work on your planning process and your delivery process all across the organization. At HP, we very clearly started with our business objectives, and our business objectives were we didn't want firmware to be the bottleneck for the company anymore, and we wanted to free up capacity for innovation. So when we looked at those things, we started looking at our value proposition, and we started looking at anything that was a cycle time driver or a cost driver that wasn't key to the value that we were trying to provide to the company, and anything that wasn't, we automated, we eliminated, or we engineered it out of the system. Fundamentally changed everything we were trying to do. The next thing is you need an executive-led continuous improvement process, and this is more than just an aggregate of what the teams are doing. Because if you've got 1,000 people and you've got 100 different teams, your strategy can't be an aggregate of all those different teams if you're going to try to coordinate work and coordinate improvement across the organization and make that piece work. So you need to start with setting objectives. I know most agile teams will work on a 2-week or a month or a 1-week basis and sort of iterate and respond. But if you're in a large organization, I found about a month works well. It gives you time to set those objectives, and it also gives you time to get alignment across the organization that those things are important and achievable and possible to do. Once you set those objectives, you don't change them during the iteration. You focus in on them, and then as executives, what we would spend our time doing is trying to figure out what was getting in the way of the organization's way of getting these things done. So you started the month with everybody in the organization bought into that these were important, they were a priority, and they thought they were possible to get done. And if they weren't get done during the month, as an executive, I had metrics I could review every morning, and I'd spend all my days out in the organization as an investigative reporter trying to figure out what was getting in the organization's way. And it wasn't going in and going and say, Dave, why didn't you get this done? It was, Dave, what happened? What got in the way? Why didn't this get done? It wasn't why didn't Dave get it done. It was what got in the way of Dave being able to accomplish this and doing that. And through that process, you take those learnings, roll them into the next iterations, and start taking plans and removing barriers that were getting in the way of the organization being effective and productive. And it was an interesting cultural change as a leader over an 800-person organization. When I started showing up at the desktop as an engineer that was struggling, it was a bit intimidating at first. But when they got used to me coming around and asking the questions and trying to figure out how to help, and they realized I was really there to help, it started creating transparency. With trust comes transparency, and with transparency comes the ability to fix things, and it's a culture that builds on itself over time. The next thing in the planning process that's interesting, and this is going to be the hardest in any organization to get the business to understand, because they manage everything else in their business with waterfall. They make commitments, they make plans, and most of the people in the organization don't understand software is different and needs to be managed differently. Probably the biggest challenge with software is we are so poor at predicting what software capabilities will add any value that literally 50% of everything we do as an industry is either never used or does not meet its business intent. Can you think of anything else in your business that has a 50% hit rate in terms of what's going to be useful in there? Executives need to understand that. They also need to understand that software is very different than everything else that you do. If you're going to build a new manufacturing plant, it may be a little different size, it may be a little different shape than anything that you've done before, but it's going to be leveraged off of most things that you've been doing for years and years over different times, and there'll be some discovery in the process. When you go off to write new software, you're doing it for the very first time ever. And it's really hard to think through all the things, and you can sit around and plan and plan and plan, and basically work your way up this slide where over time you can invest more and more in planning, but you meet diminishing returns. After a while, the best way to learn more about what your schedule is going to be is start writing code, start validating some of your assumptions and figuring it out. Most executives don't get that. And so hopefully chapter 5 of my new book is something that you can share and put on their desk, work through that, and help them understand that if they are going to be effective at managing software, they need to think about how to manage it differently. So 50% is never used. It's hard to get it accurate, but the advantage of software is if you develop it right, it can be changed up to the last minute. Anything else an executive is doing in their business, if they get it wrong and they planned it wrong, it's very expensive to change. If you poured all the cement in a factory, but you had it planned wrong, that's going to be very expensive to change. That's not the case with software. So if you look at applying waterfall principles to software, you're at risk of making the classic mistake of taking your most flexible asset, turning it into a fixed asset to deliver features that will never be used or won't deliver any business value. You need to get executives to figure that out and figure out that managing software is differently. Otherwise, they'll waste a lot of resources working all the way out to this end of the curve because they think if they just spend more time planning software, it will get better over time. Probably a lot of people more came to listen to the DevOps side of this. I've spent a lot of time implementing a very large-scale continuous integration thing at HP, and then at Macy's, I led our transition to continuous delivery for the website over across the organization. A lot of the learnings will be shared based off of that. The first thing you need to start with are what are the objectives that you're trying to do if you're going to try to apply DevOps principles. If you're going to try to release on a more frequent basis, one of my experiences, we went in and we said, well, we're going to do continuous delivery, and I think it's important to do continuous delivery. And I joined the company because they had an effort to do continuous delivery, and I read Jez's book, and I liked it, and I wanted to learn more about how to make that happen. And we'd taken one application, and we said, okay, we're going to do scripted environments, scripted deployments, automated testing, evolutionary database on that one application. What we quickly found about over 9 months, is we were struggling to deliver the value that we expected to and help the company because we couldn't independently develop, qualify, and deploy that code because it was too tightly coupled to the rest of the system. The organization was able to look back at us and see the fact that we'd invested a lot of money and time and resources trying to do continuous delivery, but it wasn't affecting their day-to-day work. And I went and spent the afternoon with Jez and brainstormed and worked on it for quite a while, and I realized we'd made a mistake that I didn't make at HP. At HP, we didn't go off to do Agile. We went off to improve our business and meet our business objectives. And so I stepped back from what we were trying to accomplish when we were doing continuous delivery and said, what are those objectives that matter? And the very first thing is we wanted to provide good real-time feedback to the developers. because we wanted to help them become better developers. We also wanted to make sure that was in an operational-like environment as we possibly could, because we wanted to make sure the operations team and the development team were aligned on common objectives, instead of developers trying to figure out how to get a feature done and sign it off on the desktop and then throw it over the wall and ask operations to try to figure out how to get it in production. That doesn't work very well. The other thing in a large organization is you tend to take a lot of resources going from release branch into production. It takes a lot of time, takes a lot of effort. That's non-value added in your system. And then the other thing we're focused on is we're struggling with the reproducibility and repeatability of our build, deploy, test process. So we wanted to clean that up. And when we focused in on these things, it really helped guide our direction. One of the biggest things you're trying to do in a large complex enterprise system is find the offending code so you can get it fixed, so you can get the quality up to the point where it is releasable. Imagine everybody knows their top triagers that go through the code in the beginning and the end game, and what they're trying to do is who brought in code that was offending. Now, if I go to Dave, and I go to Dave 6-8 weeks after he's written some code and says, hey, Dave, it looks like you brought this in and it broke all these tests. What were you thinking what you were doing? To which point Dave's going to go, what test? When? Are you sure it was me? You know, Dan gets in that code a lot. I bet it was Dan, and it probably wasn't me. And so what you're trying to do with your process of DevOps is really isolate who in the last 6-8 weeks since your last release brought in that offending code, and then give them that feedback. If you can do that within hours, I'm no longer beating up Dave for being a bad person. I'm helping Dave become a better programmer because I'm giving him the feedback in an operational-like environment to understand what it takes to make it work all the way out to the customer. And you get the organization focused on how do you transition this all the way through. The other big cultural change is developing on trunk. If you look at a very large complex enterprise system and you say we're going to do development all on trunk, at HP we had 20 some odd different products we were supporting. We were supporting MIPS processors, we were supporting ARMS processors, we were supporting little printers, and we were supporting big copiers. We had different scanners, we had different paper handling, we had all those different things. All that was done on one trunk with ARMS, MIPS, XP, and CE. It runtime compiled for the specific product. When I started talking to the organization about doing this, they thought I was crazy. They would avoid making eye contact when I walked down the hall. They could just ignore them. They'll come back to his senses or he'll fire him. This is HP, it works that way. And then over time, there was one day, Roger Tweed came up to me and goes, you know, I think we can make this work. We'll just feature bind this, we'll runtime compile it, we'll make it all work. We'll take all the if-then statements out of the code base, we'll put it in an XML file that defines the product. All the code will reference that product, and we'll quickly be able to port it to all these different products. Well, that started to make sense. It was really hard for my lead over release and test to figure out and build, to figure out how to buy into this process. He thought I was crazy for the longest time. He actually would want to come up to me and talk to me on a regular basis. Okay, branching, we're going to branch. No, Troy, we're not going to branch. Because previously we had like 10 different branches representing products in different windows of releases. Like, no, Troy, we're not going to branch. He wore out a thesaurus trying to say branch without saying branching. We said, well, when we go to this different place at the end, then how are we going to manage the code? And no, we're not going to branch, Troy. It doesn't help to use different words. And after about 2 years, 3 years, I was getting ready for our first release of the new architecture for a scanner that we were trying to get out the door. And it's like, okay, Troy, I'm ready to branch. He's like, what? You're crazy. We can't branch. And lose all the efficiencies of working on one trunk with all the automated tests and all the quick feedback. You're crazy. And then he went on a river trip down the Middle Fork of the Salmon, and there's a fly-in ranch there halfway down. It's called the Flying Bee Ranch. And he came up to me with his hat on. And he goes, we don't need no stinking bee ranch. I like that story for a few reasons. One is until you've worked in this type of environment, you can't imagine working in this type of environment. Once you've worked in this environment, you can't imagine working any other way. I've had several people leave HP, call me up, go, Gary, you can't believe this new company I'm working at. They've got no system, they've got no continuous integration, all the automated testing's not working. I don't have the coverage. I don't have the ability to program with trust and reliability and go fast like I used to. I have to go slow, and then I have to always be fixing things later, and then the code base I'm in is not stable, and I can't understand the effects of my changes. The key in this is going on that journey from non-believers to not being able to imagine working any other way. But you should start with your fundamentals. I think the biggest thing that people are starting to understand as they do continuous delivery is you're in one of these two camps. Almost everybody you'll hear presenting at conferences like Velocity or a lot of those has very clean architectures that enable small agile teams to independently develop, deploy, and qualify code. That's ideally where you should be. I'd love to be that way. I tend to work more in large legacy organizations that have architectures that look a little bit more like the architectural diagram on the bottom of the screen over there, where it takes hundreds, if not thousands of people working together to develop, qualify, and deploy code. If you try to implement the ideas that you're hearing at the Velocity conference, when you have an architecture that looks like a ball of string, it's not going to work very well. So before you start applying DevOps principles, figure out where you are in terms of that independence of teams and figuring out how to work together. I would encourage you, where possible, to architect. I think Rebecca covered some good information on how to re-architect the microservices to enable this to happen. Her comment was, you shouldn't do microservices until you've done continuous delivery. I guess my pushback on that is, you should really think about going to microservices so it's doable and easy to do continuous delivery. But you can do it with large, tightly coupled organizations. It's just more complex and you need to think about it differently. The first thing I'd start with always is your build process. This may seem obvious, but can you draw a large architectural diagram of your main artifact that you're thinking about in the system, get a green build with some automated tests, and then if you go to version 2 of each one of those components and version B causes it to go red and you get a red build, Can you just go back to version 1 of component B and get a green build? Or do you have libraries that are tightly coupled across the system that have dependencies across it so that you can't go back and forth that way? Because if you're going to build up a large complex system and you're going to keep it always green and releasable, if you can't fundamentally pull pieces out, whenever you get a red build up there, you're going to stop all the code progressing through the system and it's going to become very painful. The next thing is test automation. I think Tricia and Jay presented some really good information in the last couple hours on how to do automated testing more at the unit test level. And that works well if you have it. And a lot of legacy, tightly coupled systems, frequently you can't depend on that. Because one, if you have legacy code, when are you going to get the time to go back through it and add a bunch of unit tests? It's probably not realistic to make happen. And if the code's too tightly coupled, you're going to need test automation system testing to enable you to find all the issues and give the feedback to the developers that you need. This is too important to be left to your QA organization. If you leave it to a QA organization that's been doing manual testing for years, they will automate what they've been manually doing, and you'll find that you end up with a maintenance nightmare, and you end up with code that does not quickly localize the problem. And that's fine when you have a 10, 100, maybe 200, 300 tests, but when you start getting thousands of tests, that won't work. Jeff Morgan's got a fairly good example of how to do this with UI-based system tests where you've got business logic up in the UI. And what he does is basically he uses a puppy adoption website and teaches you how to do this. What he does is for each page, he creates a page object for each page in your website, and then when you hit that page, he has a data magic gem that automatically populates that with the data that you need. And then when you write a test, you say go from here to there. If you leave it to your manual organization to automate what they've been doing manually for years, what they're going to go through is they're going to say, okay, if I have a new credit card and I add new functionality, I want to make sure that that works. First thing I'm going to do, I'm going to go to home page, I'm going to go to men's, I'm going to go to Blazers, I'm going to go to Blue, and I'm going to pick this, I'm going to add the product to my cart, and I'm going to check out, does the credit card work? Well, that works fine when you have one or two of those tests, but when you have 1,000 of those tests that start on the home page and the home page changes, you're dead in the water. But if you've taken a page object model approach, then and they all reference that page object, the only thing you have to go update is that one page object. That enables you to keep UI testings up to date with your website and evolve with it and go with it as it comes along. This isn't the necessarily only way to do it or the right way to do it, but you need to think about how your application is going to be changing over time and how do you design your system so when it changes, your tests only need to change in one place and you can reference that. The other problem with this test is this was a checkout test to validate that the credit card worked well. If the checkout team's responsible for keeping that test passing on an ongoing basis and it's written that way, they're going to run into problems and you're going to find that they're not going to own the quality of that test because if the homepage broke or the navigation broke or any of those other things that broke that weren't associated with what they were doing was not their responsibility and wasn't their code, then they're going to come in and look at a bunch of checkout tests broken and they're going to assume that they have to fix something. Your automated test should realistically start at the checkout page. It should pre-populate it with everything you need to do and validate that just that part of the code is broken. So getting the tests where they're maintainable and quickly localize the defects is important if you're going to be running thousands and thousands of tests and getting the team to own the quality of the code on an ongoing basis. Automated testing is probably your most valuable tool when trying to figure out how to transform it. I don't know how you transform it without it done well. I think it's most frequently the thing that's done wrong in an organization. It gets maintainable. It gets where it's not maintainable from keeping it up, and it gets where it's not triageable in terms of automated. It's being able to look at the test and figure out what's going on. It's too important to be left to your QA organizations. You should get an architect that really understands object-oriented programming and team them up with your test people and sort of make sure you come up with the right approach. Next, when you're doing continuous delivery, you need to think about you can do at a small scale a very long, complex algorithm in Jenkins that sort of sets this all up and makes it work. I would encourage you to think about more of the different principles that you're trying to accomplish in here. You need a trigger that triggers off the build that says, if I've got a build, I'm going to kick these things off. You need to call your scripted environments and set that up separately. You need your automated deployment, your evolutionary database, and your testing. If you try to build that all into one script, it gets similar to what you're trying to do with test automation, is when your logic you're thinking about how your deployment pipeline needs to work changes over time, you end up having to update all these long monolithic scripts. If you can think about pulling that business logic up into your orchestrator, it enables you to leverage more common scripts across the system. The other thing that's important is if you're going to have a bunch of different environments that you're working across, make sure that you have common scripts. You're probably not going to have environments that are all consistent, but similar like we did in the LaserJet business where you have an XML that separately define the different products, take that out of your common script so that you have a common script that you work, you automate, and you reproduce it tens and hundreds of times before you ever go into production to make sure it's working, and you're just referencing the environment differences between the two places. You need to do the same thing with your automated deployment to make sure they're common. And if you have your operations team and your development team using different tools for this process, you're not going to start the cultural alignment across organizations that you need to have working on common objectives. One of the biggest values of continuous delivery is when you go into production, you've already done it hundreds of times and worked out all the bugs. If you're using different tools or different processes in production than you are in development, you're not going to see the benefits of those changes. Evolutionary database, one of the bigger challenges of keeping code always releasable is when you bring in schema changes. A lot of people will come up and say, no, I can't keep it always releasable. I got to make this schema change. We have to coordinate it. If you have your DBAs bringing that up, buy them this book, have them read it, it's solved. You do add and deprecate, you don't ever modify. Lazy instantiation, if you do alter or modify, it's like crossing the beams, cats start sleeping with dogs, all sorts of bad things happen. You can't have always releasable code. You need to do the same thing with your services. They need to be versioned and work through that process. When you're doing automated deployment, frequently what people do is they're deploying across a large number of servers. You deploy the code, you or you configure the environments, you deploy the code, you run your automated tests, and then they fail, and you start a big, long, complex triage process. And you've got to figure out what routing or what server is in a bad configuration or bad state. That can be as complex as finding bad code that was brought in the last several months and trying to localize it to the sending person. And it can be equally worse if you have the same application running on several different servers, but the deployment only failed on one of the servers because then it's very intermittent. Somebody sees it when they test, somebody else doesn't see it when they test, and you need to work through that. We ran into this in the last implementation of continuous delivery I did, and what we found is we'd spend 2 or 3 days with the team trying to get the build back to green, and there was a fail, and they're trying to figure out what was going on. They said, well, it's pretty clear here that, don't bug us again because this deployment wasn't successful. And I said, well, how can you tell that? I said, well, if you go into logfile and you look in these areas, you can see this, oh, great, let's start adding that as a test. And so similar to what we're trying to do with build frequency and some other things to localize the offending code to the fewest number of people as possible, what you're trying to do with your deployment process is localize the offending environment or deployment to the fewest number of routing devices or servers as you possibly can. So start off with configuring your routers and your server devices, run a test to validate that that's successful. At the end of each deployment, run a test to make sure that that deployment was successful. And then run your code validation when you run your system test. This isolates in a very large, complex organization the code issues from the deployment issues. And you don't want to waste your time on these things. And anytime you're finding deployment or environment issues, when you're running your final system test, it tells you that you need another post-validation test that you need to add in the process to find these things and localize them earlier. When you're building up a large, complex system, say you have a bunch of large, agile organizations, but you're hooked to COBOL, mainframe type applications, how do you build up and integrate a very large enterprise system like that? The first step is always start with your agile components, make sure that you've got unit tests that are passing, and you've got static code analysis type of things going. What you're trying to do is keep really bad code from getting in and damaging the entire system. And this is an ideal first step. I can't think of any reason why a developer would be allowed to check in unit code that's not working. Can't think of any reason a developer would be allowed to check in unit code that is not working. Jay sort of said, well, there's bad unit code and there's stuff that can be done and people write it poorly. Well, when they realize the pain of that, they'll start cleaning those things up and doing it. But if they can check in code and you've got a bunch that are failing and a bunch that are passing, how do you decide whether you can let people check in or not? The next step is breaking up the system. I found service virtualization. You can call it MOS, you can call it a stub. But how do you isolate certain parts of your system so you can localize the code? There's 3 steps that you're going to take to localize. One is build frequency. The more frequently you can build and the better feedback you can give on that, the more you're going to localize it to a fewer number of developers. The second is breaking up components that get qualified and then built up into larger systems. So if you have 2 different organizations, one on the East Coast and one on the West Coast, you may want to think about a continuous integration that builds as much of that system as frequently as you can, a system that builds as much of that as frequently as you can, and then puts the system together. Service virtualization you should avoid wherever possible as much as you can because it's something you're going to have to maintain and it's something that could be different. But when you have extremely large organizations, it does break down the complexity and enable you to keep this going. And then once a day or so, you should always make sure you're pulling the virtualization out and doing end-to-end testing. The other important thing about this is if you have very complex systems hooking to things like COBOL and some of those other things on mainframes, if you do end-to-end testing with everything, it's very expensive, it's hard, it's almost more complex to set up those big, large environments and run all the testing. In my last job, we started with 1,300 tests that we ran about every 10 days to release code on it to the website on an ongoing basis. When I left, we were close to 20,000 tests we were running every day. If I had been running all those tests against the mainframe and being charged for my processing on the mainframe, the CFO would have hunted me down and shot me because I would have driven costs out. So the idea here was test as much of the system back here, and then if I had 100 tests that sort of did end-to-end testing and used the service in a similar way, run the hundreds of tests when I was in this phase of my deployment pipeline, and then when I got to this phase, just pick the one that I thought added the most value and do the end-to-end testing on it. It's different from how a lot of organizations approach it, where they want to have the customer sign off on end-to-end testing with everything, and you spend a bunch of your time and effort trying to put the whole system together and make it work. The other thing that I would say, you heard of people talking earlier about how do you get your teammates bought in and encouraged to keep a build green and make it work on an ongoing basis. Because what you'll get is a train wreck on the system that everybody has to stop developing code, deploying it, getting it in on a regular basis, or else you're just building up a tarball and you can never get back to a green build. At HP, we had a bunch of stuff we were trying to get done. I had an organization breathing down my throat to look at the feature throughput and what was getting done. And we ran into a day that either an intermittent code or an intermittent test made it into the system, and we were getting red build. And the build team was getting frustrated, everybody in the organization was getting frustrated. The build teams added
Right, so my name is Josh. You can tell that it says Josh. And if you have questions, if you leave this room with more questions when you entered, if you have feedback, I would love to have them by email.
To respond. Hello and welcome to the board. This is our 30th episode, and I'm looking forward to today.
Okay, I'm going to spend a few minutes talking about Scrum at scale. It's a big buzzword these days, scaling Scrum. Scrum Inc. has a 2-day session we're doing this week here, and it's approved by the Scrum Alliance with credit and that sort of thing. So, we've been scaling Scrum a long time. My colleague, Professor Takeuchi, wrote a paper in 1986 about the best teams in the world, teams that they saw at Honda, Canon, 3M, later at Toyota, and they called it Scrum Project Management. And it took us 30 years to get another paper into the Harvard Business School. This last month in May, we published a paper in the Harvard Business Review, Embracing Agile. It goes through, it's for managers, it goes through all the ways that managers can screw up a Scrum by not understanding what Agile is and how to remedy that. And it was fascinating because the leadership of the Harvard Business Review called in their employees after they published the paper and asked their employees, what are they doing to screw up agility at the Harvard Business School Press. So Scrum has been around a long time. Now, interestingly, we work with many companies. When we look at what they're doing, they're radically different. So we have a Defense Department contractor who lost a $400 million radar contract to a Scrum competitor. And they came to us and they said, the government just told us we will never get a...
Hi, everybody. We're going to go ahead and get started. Are we okay? Yeah, okay. Hi, I'm Yvonne Ajay. I'm the VP of Benefits, and I sit over normally at 123. And it's my pleasure today to welcome Dr. Jeff Sutherland, who's going to talk to us about his new book, Scrum. How many people have heard of Scrum, the term? Oh, wow. Okay. So I'm completely outnumbered, and you probably all know that it's a term that comes out of rugby, which I did not know before reading the book. But he's going to talk to us about Scrum, which is an approach to work and project development that he's used in different areas. I'm not going to go too much into his background because he's going to go into that as he tells the story. One thing I will say is that in reading the book, it really resonated with me about how we work at Google, the idea of working in small teams, providing a lot of autonomy, having managers get out of the way and really facilitate the work that their teams are doing. So without further ado, join me in welcoming Dr. Jeff Sutherland.
Thank you very much. I've been doing a book tour for the last couple of weeks, and last week I spent a lot of time in Silicon Valley meeting with all the larger companies there, but I didn't hit Google this time, so I'm doing Google here in London. The talk about the book started with a TED Talk, and they had this video front-ending my TED Talk, which I really liked because it was kind of the French view of what Scrum is. So they had these big concrete blocks and shattering on the pavement. Then they said Scrum is about hacking leadership, which Google has done a great job of, but most companies have a problem with it. The TED Talk was in France, so I decided I'd start by talking about the Declaration of Independence because the French had helped us win the American Revolution. They sent General Lafayette over to fight with George Washington, and then some years later they gave us the Statue of Liberty. So I went back to the Declaration of Independence and said, every citizen in the United States, and maybe even in Britain as well, is entitled to life, liberty, and the pursuit of happiness. But how are we doing with that? If you look at the average person, you're living in a happy bubble here at Google. But the rest of those people out there, they're miserable, okay? People hate work. The only thing worse than going to work is being sick in bed. And the New York Times has even done an analysis of why people hate work. It's because, you know, they're working hard, they never have enough time, never get to work on what they want. They're working late, they're working weekends, they don't have time with their families, they have no life, they have no freedom, and as a result, they're very unhappy. So, you know, the root of all this is, for most people, they're under the gun to deliver something, a product, a project, but as Robert Burns says, the best laid plans of mice and men often go wrong, and you wind up with a lot of pain and suffering instead of the promised joy. And I learned about this kind of thing as a cadet at West Point. Here I am at Beast Barracks. I'm being yelled at by a first-classman. After running around all day, being yelled at night, we had what they call the shower formation. And what he's doing is telling me to get my chin in hard enough to drench my bathrobe with sweat, because only when you were drenched did you get to go into the shower. So I had to learn how to generate twice as much sweat in half the time. Okay? Standing next to me is four-star General Barry McCaffrey. So I learned how to deal with really difficult situations as a West Point cadet. My last year there, I was actually got the job as training officer for my company. And it was Company L2. There were 24 companies in the Corps of Cadets. And one of the primary responsibilities of a training officer was to get the cadets to march really well in the formal parades. We had at least 3 of them a week. And they always had a lot of tourists there. The brass was all there. And the problem was, my company was Company L2, and they had been known for 100 years as the Loose Deuce because of their sloppy performance on the parade field. And no matter how much overtime we spent marching, trying to get them to march better, the culture of mediocrity was just pervasive. So I decided I would try something very different. And instead of talking to them, instead of trying to coach them, I just started putting up on the wall in colored notes after the parade all the scores. You know, we lost 10 points because Charlie had his sword stuck in the dirt in the middle of the parade field. We lost 5 points because the platoon turning onto the parade field was not aligned. We lost 8 points because the company commander did not articulate the command at the right time. To everyone's amazement, within 3 months, Company L2 became the #1 marching company in the Corps of Cadets for the first time in 202 years. It's unbelievable. And it was all because of making the work visible. They self-organized to do a great job. And about that time, one of our most famous graduates died, General Douglas MacArthur. He was very close to the Corps of Cadets during the last years of his life. His last speech is memorized to this day by every cadet. And he had specified when he died that after laying in state in Washington, D.C., he was to be pulled by a riderless horse. His casket would be pulled by a riderless horse to his grave, and marching behind that casket would be a company of cadets. And so Company L2, being the #1 marching company in the Corps, was selected to bury General MacArthur. The last parade of the year, the graduation parade, my future father-in-law was there, and after the parade he said, "Jeff, who is that last company in the Corps of Cadets?" They seemed to float across the field. They were different than every other company in the Corps. I said, well, those are the guys that buried General MacArthur, and they will never forget it. So that taught me one of the first principles in Scrum. If you make the work visible, teams will self-organize to do great things. Another thing I learned at West Point from another famous graduate, General Eisenhower. I slept in his room when I was a cadet. We had a gold plaque on the mantelpiece saying General Dwight D. Eisenhower slept here. And sometimes the light reflecting off it would wake me at night, and I would think, you know, what was General Eisenhower thinking when he was a cadet? Well, he had a famous quote called, "Plans are worthless, but planning is everything." When he planned D-Day to take the beach at Normandy, he did a lot of planning. But he knew as soon as the first shot was fired, that plan would be shattered, and the teams would have to self-organize to take the beach. I learned about that firsthand as a fighter pilot. When I graduated, I went into the Air Force. Here's a photo of one of my fellow pilots getting blown out of the sky over Hanoi by a SAM missile. And what I learned is that if you follow the flight plan that you made over the most heavily defended airspace in the history of aerial warfare, you will get shot down. And in fact, about half of us got shot down. Most did not come back. Ed Atterbury was actually captured. He wound up in Hanoi Hilton. He was a tough character. He escaped, but they recaptured him and then tortured him to death. So that was a typical fate for half of my fellow pilots. So I learned when crossing the border that you needed to go into an evasive maneuver and never stop evading. And only at the last moment, in a very unpredictable way, would you pop over the target and then back in the evasive maneuver. So I credit my survival to not following the plan and a lot of luck. Now, when you come back from an experience like that, you have a lot of emotional reactions. The first one is you feel guilty, like half of my buddies are dead and I'm alive, like it's not fair to them. And then the next feeling you have is exhilaration, like thank God I survived. And then the third feeling you have is like, well, what am I going to do for the rest of my life? I've kind of got a bonus life. I should have been dead, but now every day is a bonus day. So I thought about it for a while, and I asked the Air Force to send me back to Stanford University to get an advanced degree to go teach at the Air Force Academy in the mathematics department. They agreed to do that, and that gave me a lot of time to think about life, the universe, and everything. I studied math, probability statistics, computer science. I spent a lot of time in the AI lab. The technical guys might appreciate it. Any of you Lisp programmers in here? Don't do any Lisp anymore? One of the two godfathers of AI was running the AI lab at Stanford, Professor McCarthy, and he would come by. I was there just as a student doing a project, and he would come by every day complaining bitterly because I was using 10% of the compute power in the AI lab for my checker program. I was writing a program that would play checkers and beat people, play against computers, and that sort of thing. So I got christened very early on by some of the leaders in artificial intelligence at Stanford. I was also strongly affected by a mentor, Professor Kachadurian, on the left there. At the time, he was the chair of the Department of Psychiatry. He had been a student of my father-in-law, a very distinguished physician, who he viewed as a god. I could never say anything negative about him or I would be reprimanded immediately. But he took me under his wing and gave me some guidance. And my favorite courses, actually, at Stanford were in the medical school because the surgeons reminded me a lot of fighter pilots. They had the kind of same mentality. And the course I was taking, they were mainly focused on biostatistics and clinical trials and things like that. But he advised me not to go into medicine as a clinician, but to build on my experience, brick by brick, build on what I already knew. As a result, when I got to the Air Force Academy and started teaching, I decided to continue my advanced degree work at the University of Colorado Medical School. So I would go nights and weekends. I would work on my degree while I was teaching math at the Air Force Academy. And one of the guys that was most important to me there was a guy named Dr. John Baylor. Now, he was editor of the Journal of the National Cancer Institute, and he had just written a paper showing that there were more women that got cancer and died of radiation dosage from mammography than were saved by early detection. And the American College of Radiology was furious, so they wanted to tar and feather him and run him out of the United States. What happened is that the National Cancer Institute convened a blue ribbon panel that met for 6 months. At the end of those 6 months, they determined that Dr. Baylor was exactly right, and all the standards, protocols, and treatment for mammography were changed. And to this day, I noticed even in the last year, they're fine-tuning that based on Baylor's recommendations. So I had a lot of respect for him as a person who would stand up for the right thing and deal with any flack that came his way and do something that's useful to society. So I said to him when he visited the medical school, I said, Dr. Baylor, I said, I'd like to write a PhD thesis. Do we have any PhDs in here? Google hires PhDs, right? And a lot of PhD theses, they just wind up on the library shelf gathering dust. And I said, I don't want to do that. I want to write something that is useful to people. Can you help me with that? So Dr. Baylor said, well, I have a couple of problems that have been puzzling me for some years. So he gave me 300 clinical papers. He said, here's 300 papers out of the medical journals. And in every paper, you will see graphs. And the graphs are dose-response curves. We put some carcinogen on the back of a rat, and it grew a number of tumors. And there were papers on rats, mice, monkeys, rabbits. Also papers on different types of human cancers, different types of cancers in different parts of the world. He said, every paper has a graph that's different. Explain it, and then we'll give you a PhD. He said, the only problem, he says, you're going to have to model how a cell becomes malignant. And nobody knows how that works. So you're going to have to figure out what causes cancer. And then mathematically model it on the computer, and then map it to all the data at the National Cancer Institute. We have huge amounts of data on population-based data in many parts of the United States for many years, and we also have data on different types of tumors and so forth, different types of populations. So when your model starts with a cell, and it maps how it grows into a tumor, and then how a person winds up in a doctor's office, and then how they get treated, and then that maps into all the data. So that's a lot of this kind of stuff you're doing here at Google right now. Then you'll be done. He said, but don't worry, because the leading cancer researchers in the world are all submitting papers to me, and I will get them to review anything you do, and we will kind of guide you step by step. So at the time, we didn't understand what we understand today. Today, with the DNA sequencing, we know exactly what happens. The cell starts at the bottom red cell, mutates, turns into an orange cell. And then that orange cell may go in a couple of directions through mutation. And if it goes off to the left, if it goes to the right, it goes to leukemia. If it goes up to the yellow, it starts to turn into early non-malignant tumors. It keeps on mutating, goes up into the green, then gets to the blue. Now you're starting to get the first malignant cell, uncontrollable growth. Then you treat it with radiation and chemotherapy, and it mutates again, and you've got a drug-resistant metastatic tumor. We didn't know any of that back when I was doing my thesis. So I went to work trying to model a cell and made some assumptions about what needed to happen to change that cell. It took me about a year to complete the first program that I could run on the computer. And my first run used a third of the computer science department budget for the year in the medical school. They told me I could never run that program again. But what it did show is that there are exactly 4 steps to malignancy, which now we know from DNA research. So the work we did became the fundamental model for cancer. So it has been very valuable. But the question was, I needed 1,000 runs of this program to get my degree, and what was I going to run it on? Well, the kind of computing that we did, you can see, this is actually a simpler problem later done at NASA. It's kind of evolutionary computing. Everything I did was based on evolutionary biology, and so is Scrum. Scrum is based on evolutionary biology. This particular example is for how do you build the best possible antenna transmitter for a satellite. Well, instead of having hardware designers, let's build evolutionary algorithms on a computer. And then we can run hundreds of thousands of millions of simulations. And we can wind up selecting the best antenna design. Today we can probably put it in a 3D printer and print it. So the best thing is created untouched by human hands. It's just software. This particular one, you can see, it was actually deployed on Space Technology Mission 5 in 2006. It was launched and it worked perfectly. So in order to run this, this was done at the Ames laboratory in Silicon Valley. They needed a highly parallel system, 36 processors. And so my problem was, where was I going to get a system? This was 25 years earlier than NASA. Well, I went to work with the head of the computing lab, and about that time, Tandem had come out with its first multiprocessor system, fault-tolerant, non-stop. And we decided to buy 2 of them, 2 multiprocessor systems, one for the hospital and one for the medical computing lab. And I was able, it had a unique architecture that enabled me to capture every spare cycle on every processor without interfering with the normal work on the computer. So for 5 years, every processor on the Tandem system was pegged. And I could get a run to complete in about a week. It would take about a week to run to completion. But because the Tandem was fault-tolerant, non-stop, it always ran to completion. I became a professor in the university when I got my degree, a professor of radiology, biometrics, and preventive medicine. And I had millions of dollars every year in grant funding from NCI to cancer research, mostly mathematical epidemiology in that area. And because of the Tandem work we were doing, a large banking company came by one day and said, hey, Jeff, you've got the best team outside of Silicon Valley for Tandem programming. And over at the bank, we're using these Tandems to roll out automated teller systems. So we're running 150 banks all over North America. And ATMs are exploding. We're having a lot of trouble with this technology. But, over the medical school, you guys have all the knowledge, but over the bank, we have all the money. What if we put the knowledge together with the money? And they made me an offer that my wife couldn't refuse. She's sitting back there. I wind up as vice president for advanced systems at the bank. Now, we had all kinds of programmers at the bank, but the largest group of programmers was COBOL programmers. Anybody programming COBOL here? They probably don't hire any COBOL programmers here. We have COBOL programmers. And I looked at what they were doing. Their projects were always late. And the management were always upset. The customers were always screaming. And they reminded me of, Romans rowing these galleons, harder, harder, faster, faster. This guy cracking the whip. And I looked at what they were doing, and I was just a guy from medical school. I had worked at Bell Labs. The guys that I was working with were like trying to get enriched users at the language, and they were giving me their tools, and we were emulating how they did it at Bell Labs. It was a small team. That's really where Scrum comes from. The idea for Scrum comes from. But I saw these huge projects, always late, and they were run with these Gantt charts. They were much bigger than this one. The bank had one that would fill the whole wall of this room. Thousands of tasks. Every task had a date and a name on it. And I looked at that, and as a mathematician, I said, if one of those dates is missed, they're all going to slide, and the project's going to be late. What's the probability of that? It's 99.9999999. Projects are guaranteed to be late if you manage them with Gantt charts. So I went into the CEO's office, and I said, these guys are crazy. They set up projects that are guaranteed to be late, and now the managers are running around, and they think if they have more meetings, more reports, and more micromanagement, they can actually bring them on time. I said, it's never going to work. I said, I want you to give me the worst business unit in the bank, which is the one running these ATM systems. It was bleeding the most red ink. And I said, I want to run that as one team with a bunch of small sub-teams. And I want to run it as a little company within a company. And every month we'll present our financial statements to you and the senior management. You can be our board of directors. And then the rest of the time you stay out of my company. I don't want you messing it up, and then I will fix this. So he thought about it for a while, and he said, Sutherland, if you want this headache, you got it. So I said, I want everybody, sales, marketing, support, engineering, everyone. And we broke them into small teams. You know, in Scrum Guide we say 3 to 9, but it turns out Harvard research shows clearly that the right size team, optimal size, is 4.6 people. So it's somewhere between 4 and 5. We ran them in short cycles, weekly sprints. At the beginning of the week, we built a product backlog that was prioritized by business value, particularly for the engineers that were coding. We had a financial expert come in from the bank and estimate the dollar value of every feature. That, combined with the work estimate, allowed us to prioritize. At the end of the week, they deployed those features. And in less than 6 months, it became the most profitable business unit in the bank. Okay, so this was the first prototype of Scrum. Now, in order to get rid of the Gantt chart and manage the product development successfully, the sliding off the end of the Gantt chart reminded me of training new pilots on how to land a high-performance jet. They were always coming in high, and if you came in high in one of these jets, you could wind up halfway down the runway before you touched down. If you did that, you could slide right off the end of the runway. It happened to me twice. Fortunately, the plane I flew was designed to land in an aircraft carrier and had a tail hook, and they had changed at the end of the runway. So both times I caught the hook instead of sliding into the buildings or the trees and creating a big smoking hole. What would happen? So I thought about, here's the plane I flew, an R-4C Phantom. You notice coming down final approach, he's making small incremental changes every step of the way. He's looking at altitude, airspeed, rate of descent, heading, and he's constantly scanning and adjusting to bring that down. Those planes were designed to land on carriers, and that meant you slammed them on the end of the runway, and then that would absorb a lot of shock and slow you down. So one of the goals was to bang it to slow you down. You see he's going to make a perfect landing. Bang, on the end of the runway. The chute pops. Nice landing, okay? So I needed them to do a project just like that. So what I added to making work visible that I learned at West Point was the burn down chart. So they could see every step of the way exactly where they were in the flight path. Now, after fixing this business unit, the bank bought a company in Cambridge, right next to MIT, across from the business school at MIT, a new banking software company, new technology. And so I went there, and they had a project. Later, I consulted with Bank of America for the same project. Bank of America was spending $350 million to do what they were doing. It was already years late, and they wanted me to fix that. We had bigger problems than just the project planning, because in order to get technologies that would scale to multi-billion-dollar banks, we wound up having to do things like build the first object database system for high-volume transaction processing. So I built a technology group out of guys out of MIT. We ran them as small teams. We started building these new technologies. And because of my work with object databases, I was hired in to run an object database company. And I was working away on the database company was right on the campus of MIT. I was working away in the object database company, and 5 graduate students came by. The MIT AI lab was just about 3 blocks down the street. They came by and they said, hey, we need some lab space to build our robots. We're starting up a robot company, which eventually became known as iRobot. And you have some lab space. Will you rent us a couple of rooms so we can build our robots? I said, sure, why not? It's interesting technology. And we have the space. We'll make a little extra money. So they're building these 6-legged robots, and about every other day, the robot escapes from their lab, comes walking into my office, trying to hunt me down. It had infrared heat-seeking sensors. And a senior professor at MIT was supervising the students, and he was a co-founder. He would come by on Fridays. One Friday I asked him, I said, Professor Brooks, explain to me how this robot works. He said, first of all, you need to understand, for 30 years, we tried to build an intelligent system at MIT, and it's been a complete and total failure. No matter how big a computer, how big a planning system, how big a database, nothing worked. The best we've been able to do is a smart chess program. So he said, what I've done is this robot has a chip in every leg that knows how to move a leg. There is no central processor. It has a chip in the spine that can coordinate legs, and it has a neural network chip in the head that figures out what to do. He said, here's the neural network chip, it's blank. He plugs it into the robot, flips the switch, all of a sudden the leg starts flapping like spaghetti. It wobbles to its feet, and then it starts walking around, banging into things. It looks like a baby learning how to walk. But within about 3 minutes, it's running around the room. Wow, that's amazing. And he said, yeah, it learns how to walk for the first time every time you turn it on. So I thought for a minute. I said, I used to have these COBOL programs back at the bank, really, really slow. Maybe if we gave them some simple rules like the robot, they could sync their neural nets every day in a daily meeting. They could bootstrap up into a super intelligent, high-performing team. Do you think that would work, Professor Brooks? He said, I don't know. Why don't you try it? So I did. It's called Scrum. It's a bootstrap. Now, back when I was a professor of radiology, we used to use early computing PDP-8s for radiation therapy. Anybody ever seen a PDP-8? You're probably all too young, maybe. And those, yeah, you saw it in use. The ones with the paper tape that starts them up. The early ones, you had to feed a paper tape into it. It had hundreds of lights on the front. You'd feed the paper tape in, go zzz, and then whoa, all the lights would start dancing. It was like magic. And the paper tape was the bootstrap. So you still have that bootstrap on your laptop. It's in the boot section on your disk. So what I find is about half of the Scrum teams out there in the world, they change an instruction in the bootstrap. You know, like if you went into the boot sector on your laptop and you changed the bit, and then you tried to turn it on your laptop, what happens? The lights don't come on, okay? So for about half the Scrum teams in the world, the lights don't come on. But if you run all the instructions, the magic happens. So we got this working. About the same time, a company, the first 4GL language company in the world, I think, Easel Corporation, the CEO had taken the company from a stock price of 3 to over 50. But then the stock was starting to go down because of a lot of competition. And so he went and he acquired a new technology company in Germany. And he came and talked to me and he said, Jeff, we need a new product suite to replace our whole 4GL language technology. We need it in less than 6 months. I bought a German company that has the base technology. I need someone like you that's built object database systems to come in and figure out how to get this new product out in 6 months. We'll give you a small team of the best people in the company, and the technology, base technology, the Germans have it. So it sounded like fun. So I said, sure, why not? So I come into the company and I watch these guys working with a prototype of the new system. We figure out we have really big customers, like Ford Motor Company, 1,000 IT workers, using our 4GL language to build all their internal apps. We work with these large customers. We figured out what they really wanted. And what they needed was a system where they could design what they wanted to build using, at the time there were many different object-oriented analysis designs, technologies that have all converged pretty much into UML today. They could create a design, and then the system would auto-generate all the code, all the bindings to any relational database, an initial version of the user interface. Then they could dive into the code, change the code, and it would regen the design. So the first round-trip engineering kind of environment. It still exists today. It's called Object Studio, and it's used for wolf-pack programming, where you can get a dozen people hacking the same code simultaneously. I went to a user group meeting one night, and in 1 hour we created a game that we couldn't create in a week by 12 guys hacking, okay, on the same code at the same time. And it's a small time-based environment, so every time you make a change, immediately the virtual machine will immediately boot up and run. So I watched these guys working in this kind of environment, and I noticed they're trying to get this next feature to work, but sometimes they go days, sometimes even weeks, and they're struggling. It just won't work. But then all of a sudden, like magic, the feature works. And I watched that happening, and as an evolutionary biologist, I knew that over at Harvard University, Professor Jay Gould was writing papers on punctuated equilibrium. Now, punctuated equilibrium it tries to explain why a species can go 1,000,000 years with no change, and all of a sudden it changes. And over at Thinking Machines, one of the first supercomputer companies, Danny Hillis was working with Harvard and modeling on the supercomputer, a highly parallel processing supercomputer, what happened, if a squirrel goes 1,000,000 years before it pops out of the trees and flies, what happens to the squirrel in 1,000,000 years? What's going on? And you don't see any change. And what he was able to simulate on the computer was that multiple parts of the organ system make subtle changes, and only when 5 or 6 different major organ systems reconfigure themselves in exactly the right way, does all of a sudden the squirrel fly out of the tree. So I said, guys, what you're seeing here is punctuated equilibrium, but it's in software. So we need to stop trying to create new features. What we need to do is ask ourselves, what is the smallest change we can make to push the system in the right direction? And we need to understand the component architecture of the software and make that change in the right component. We make that change, the system runs, we look at it, we say, okay, what is the next smallest change we should make? The only people that have understood this in the last 20 years are the Google guys in New York. They grilled me for 4 hours one night. They would not give up until they found the secret sauce of Scrum. So maybe some of you will pick it up here in London. If you do this, the features will pop out like magic in less than 20% of the time. If you can do that, you become invincible. Nobody can compete against you. Now, the other thing that we had to change was, as we were building the system and the tooling that people were going to use the system, we were working on the organizational structure. How should the team be organized? How should it run? And we knew there were 3 major problems. One is Conway's Law. The structure of the organization was reflecting code. So we knew Ford Motor Company had a hierarchical command and control culture. So that meant the code would be hierarchical command and control. That meant it would be a complete violation of good object design. It would be brittle code, hard to maintain, impossible to refactor. You'd build out an architecture that would lock you in concrete, so the next feature that needed an architectural change, it was like impossible. So we had to create an organizational structure that would get around Conway's Law. The second thing we had to deal with was Brooks' Law. Brooks' Law says, as you increase the team size, it delays the project. In fact, we had data from hundreds of projects showing that if you take a team of 6 that takes a year to do a project, if you add 4 people to the team and make it 10, then they will take 18 months to do the 12-month project. Add 4 people, delays the project for 6 months. So we knew the team size had to be down around, we didn't know the magic number 4.6 at the time, but we knew 6 people or less was probably the right number. The third thing we had to deal with was what Peter Drucker, who invented management, the concept of management, called the cuckoo effect. In a great book he wrote on entrepreneurship and innovation, he has a chapter on the Kuku effect. And that is, if you do any innovation inside a company, except for Google, it will be perceived as an alien organism, like a bacteria or virus. And all the antibodies of the corporate culture will rise up and try to crush it immediately. Okay? Now, as a pilot, I knew about Lockheed's Skunk Works. And what Lockheed did was take a bunch of guys and put them in the desert in California where nobody could bother them. And then they could build something like the SR-71 or the first stealth bomber in 10% of the time at 10% of the cost. But I needed a system that would actually work inside corporate headquarters. And so the way Scrum teams are conceived and operate, they're able to evade the immune response of the corporation. Because in the early days, nobody ever approved Scrum. Okay? It was always stealth Scrum implementation by developers who wanted a better way of working. And so we need to build it out so that it would infinitely scale. And these double circles are like, we call it Scrum of Scrums. It's really a virtual team that coordinates the activities of multiple teams. So you can think of, one of them being Google Maps, has a bunch of teams making Google Maps. But then there's another team up here like Zillow's using Google Maps to add real estate prices. And then maybe somebody's using Zillow. So it enables a huge mashup. This is basically the way the internet is running, right? So this organizational structure became really important. How do you scale Scrum? Now, after all of this was pretty much put together, we needed a way to explain it to avoid voter time. So we started researching the literature. Hundreds of papers. The best one we found was by the world's leading experts on knowledge generation, Professors Nanaka and Takeuchi. And they had written a paper in 1986 called The New Product Development, in which they described 3 major styles of project management. Type A was the way NASA built rockets and the space shuttle. Big requirements documents, handed off to the analysis team. Took them years to get the requirements. Then the analysis team would take more years, another big document, handed off to the design team. More big documents, more years, implementation, more years into testing, more years into deployment. 10 to 15 years later, the rocket launches, it blows up in the pad, go back to step 1 and do it again. Nanaka and Takeuchi were consultants to Japanese management teams. They brought Fuji Xerox management to NASA, showed them how they work, and Fuji Xerox came back and tried to implement that. But of course, as soon as they did, it's a fundamentally flawed model. We know today the failure rate is 86% for this traditional model of project. So they immediately started getting failures. But the Japanese had been trained by Edward Deming after World War II to do root cause analysis of failure. And what they found was big documents handed off between departments causes 4 out of 5 projects to fail. So they banned big documents and they banned handoffs and went to what they call the sashimi style of project management. Everybody's face-to-face all the way through. But the best teams, Nanaka and Takeuchi found at places like Honda, Toyota, 3M in the United States, lean companies, where the teams were cross-functional, working so closely together. In Paris, there are Google teams. They sit around the table all day. They have a Scrum board. Whenever anyone comes free, they go immediately to the top story on the board and work on it. It doesn't matter whether they know it or not. If you don't know it, you learn it. Okay? So everybody knows everything on the team. That's the way Toyota builds cars. If there is any impediment, that goes to the top story on the board, and the team works on that first. Radical cross-fertilization, radical impediment removal. You might go visit these guys in Paris. If you're not doing that, really fast team if you do that. They called Type B and Type C, reminded them of the game of rugby, the Scrum formation in rugby. So they said, we're going to call this Scrum Project Management. So we said, that's it. We'll call it Scrum Project Management. And then we talked to Ford Motor Company executives. We say, it comes from Toyota. It's a car company just like you guys. So it'll be believable. And in there, they noted that all of these teams, the best teams, had 3 things in common. One, transcendent goals. Like the Prius team at Toyota. The goal is to start greening the planet, get twice the gas mileage. All these teams had autonomy. They chose their work. They decided how to do the work. Nobody's micromanaging their work. And through cross-fertilization and cross-learning, they booted up into super-performing teams. And that's an exhilarating feeling when you want a great team. So this transcendent goals, it's all about a better life for the world and for the people. Google kind of has that, do no evil. How's that working here? Autonomy, you have a lot of autonomy here at Google. I don't know how well you're working in teams here. It doesn't sound like you're working as well as the guys in Paris. So I'm looking at your faces when I talk about that. Okay. Real team performance requires real collaboration. So life, liberty, and the pursuit of happiness, having a great time, is fundamental to Scrum, okay? And it's based on lean product development at Toyota. We've been meeting with the lean people. I just came from Lean IT conference. They say, what Takeuchi and Nanaka were looking at was lean product development at Toyota. So this was all done in 1993. In 1995, I called up my buddy Ken Schwaber. He's the CEO of a project management software company. I said, Ken, I want you to come in and look at this new way of working. Those methodologies with the Gantt charts you're selling, they don't work, but I've got something that really works. He came in and spent 2 weeks with the team. He said, you're right. So I said, what I want you to do to Ken is I was working internally with the company. I want you to go out and promote this in the industry. We need to make it open source, free. And so he agreed to do that. 6 years later, we wind up in 2001 at a meeting of 17 experts on what they called at that time lightweight processes. The main processes were Scrum and extreme programming. And one of the Scrum guys had read this book called Agile Competitors, 100 hardware companies who were lean, but what they added was customer involvement and product creation. They call that Agile. And so he argued that we should call what we're doing in software Agile. That's where Agile came from. And the second day of the meeting, during a break, Martin Fowler, famous author, went to the board. Actually, 9 of the guys went out to ski slope, 8 of us back in the room. Martin says, it'd be really good if we could agree on something before we leave, because we've all been arguing and debating. What can we agree on? Well, the first thing we agreed on was great teams were the most important thing. And Bell Labs had done 10 years of research showing that the interactions of the teams was what produced great performance and great product. And we said, it's not that we don't like processes and tools, but the teams are much more important. Processes and tools can slow you down. The second thing we agreed on was having working software in short increments and deploying it and getting feedback is critical. It's not that we don't need some documentation. In fact, today we know for a medical device, you need 5% of the documentation that people used to have for FDA compliance. So you need some documentation, but a lot less. The third we agreed on is that getting the customer involved in the creation of the product, and Scrum as the product owner, is critical. And the fourth thing was responding to change or following a plan. We wrote all this in 15 minutes. After the break, the other 9 guys come back in. Ward Cunningham, one of the XP founders, the inventor of the wiki, there's a great article this week in the press on how Ward helped to create Wikipedia because he invented the wiki. He also invented the user story. He invented fitness, one of the acceptance test-driven development tooling. He was kind of the lead technical guy. He walked in, his mouth dropped, he looked at it, he said, "That's awesome," and not a single word would change. So 15 minutes, we published this, and the whole world started to get agile. So major changes going on. And what's happened is it's changed the way people work. So here's the worst project in the world today. It's $143 billion over budget, the F-35. The latest delay is 13-month delay because of testing. And last month, one caught fire on the runway. They're all grounded. Here's the best airplane in the world. My company is consultants who Saab Defense, Saab Gripen. They build it with Scrum. Every 6 months, there's a new major release of the operating system. It's like a new release of Windows. It's probably as big as Windows. But along with that new release is all new hardware. So every 6 months, they have a new version of the plane. It's faster, it's lighter, it's cheaper, it has better technologies, better radar, better targeting systems. It is, by today, it's 3 generations ahead of the F-35. It is also the cheapest aircraft in the world. Less than 20% of the life cycle cost of the F-35. Less than 20% to buy and less than 20% to maintain. And we're seeing that in many different hardware scenarios. For example, in the middle there, you can see a John Deere piece of agricultural equipment. In John Deere, they use Scrum to manufacture that stuff. They get 700 or 800% improvement in productivity. And what we're seeing consistently is that the price tends to drop to 20% of the competitors' prices. So Scrum is spreading outside of software, back into hardware where it started. It's also spreading across domains. You can see down in the bottom picture is Joe Justice. He runs our hardware practice. He's coaching a car company. They build cars in 1-week sprints. But it's spreading out in Silicon Valley. I had a group like this. I said, how many have run your wedding by Scrum? 6 people raised their hands. Anybody run a wedding by Scrum? It's great for weddings. But the leading implementation of Scrum today in the world is in education. And we see this both in the US and Europe, but the best implementation is EduScrum in the Netherlands. And I visited the school where it started. It's high school, teenagers, and the bell rings and the kids come running into the class. They're in teams of 4, and they have these Scrum boards you can see in the slide with sticky notes. They immediately run to the wall, put it up on the wall, have a daily meeting, it's usually less than 10 minutes. They run to their seat and start working. The teacher just stands there watching. He says, I'm the product owner. I don't get to talk unless I have a question. I just ask them to make sure they're done. I asked the kids, is it more fun doing this than the old way? They said, yes. They screamed, yes. They said, we have a definition of fun for every story in addition to a definition of fun. I said, what about your grades? They said, well, on a scale of 1 to 10, which they do in the Netherlands, the average grade is 5 in the waterfall classes. But in the Scrum classes, it's over 7. So really significant grade in performance. How about speed? They said we finished weeks early compared to the rest of the class. One of the most interesting things I noticed was a handicapped girl in a wheelchair came wheeling in. She's right into the daily meeting, running to the desk with a wheelchair, just like everybody else, and totally involved as a first-class citizen working. They told me she can only be there 2 days a week. But because of the way Scrum works, it just totally gets them engaged. And one of the kids who had been autistic and who hardly talked to anyone 2 years earlier, he said, autistic kids are real valuable players on these Scrum teams because they're great at visualization and planning. And he said, I became a Scrum Master, and he described what he was doing and how he was leading the team. This kid who could hardly talk had become a great communicator and a leader. It absolutely transforms the kids. And the teachers say, virtually all motivation and disciplinary problems just go away. The teams are self-managing. One of the girls said, I went home for family dinner a couple of weeks ago, and my father was really depressed. And the family asked him, why are you so depressed, Dad? He said, they implemented Scrum in my IT group today. So the daughter says, well, how do they do it? What are you doing? And he explains. He said, you're doing it all wrong, Dad. You have to do this, you have to do that. So in the future, your children are going to be training you how to have better teams here at Google, if we can get it into the UK school system. So all of these stories and many more This book is really a book that's beyond IT. The goal was more than 80% of the stories outside of IT, where Scrum is going, and all these stories that really are the background of Scrum and where it comes from, because it has no modeling, AI, that's where it all comes from, capped by the Toyota Lean product development experience. So I think you've got books for everybody, right? So hope you read it and enjoy it.
Yes, we have books for those of you who came early and sat up front. We have time for just a couple of questions, and I'm going to ask you to use the mics. Any questions?
Hi. So I've been using Scrum a bit, and I really enjoyed it. And my question was about the burn down for 1 week sprints. What's the value of that? When it was the Schwaber 30 days, you could get some kind of trajectory. But when you only have 5 days, it's very hard to correct something that's gone out of, when you've already had 2 or 3 days, there's not a lot of opportunity to change.
That's what people say when they're starting off with Scrum. But in my company, we run our company completely by Scrum. We run all in 1 week sprints. We use some tooling because we have a lot of distributed people. It has a burn up instead of a burn down. But it gives us quite a good visualization of what's going on. But for a lot of companies today, particularly Google and Mountain View, I don't know how you're working here, you're in a continuous delivery mode. So you figure out how much you delivered this week, burning up. Is that happening here? You guys delivering stuff every day? Production? Yeah. So you just burn up for a week. Most companies today don't use 4 week sprints anymore. I mean, Ken still likes 30 days, but probably 70% of Scrums today have 2 weeks, few 3 weeks, few 1 week. We find that 1 week sprints are more intense, so you have to have a team that wants to really be focused and disciplined. And if you do that on a weekly cycle, you get more learning. It's really the learning cycle that propels the product.
I've worked at a couple of different companies that have done Scrum, and there seems to be quite a vast different. Was that kind of the intention of Scrum? Were you leaving it very open to interpretation? Or do you find that Scrum is kind of misrepresented by some companies?
Well, the Scrum guide, we try to keep minimal, the middle framework. But the misinterpretations that we see are really extreme. About half of the Scrum teams in the world can't deliver anything. And so they're not doing it the way Ken and I are talking about. We have Scrum teams that are spending a year doing 2 week sprints for requirements for 6 months. And then 2 week sprints for coding with no testing for 3 months. And then they're never done, so the project's always late by this time. And they think for a lot of coaches,